Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and we are continuing our video series today on algebraic techniques by looking at substitution. And this video is aimed at students in junior maths classes such as grade 7, grade 8, possibly if you're in Key Stage 3 in the UK. So basically those junior mathematicians, and also if you're in senior mathematics and you're wanting to brush up on some of the foundations, this is also a great video for you too. So first of all, let's talk about the word substitution. What does that mean in terms of algebra? Well, it comes from the word substitute, which means to replace. And we see this a lot in real life in different situations. So if you have a substitute teacher, it means that teacher is replacing your regular teacher. If you're playing basketball and you have an injury, you'll be subbed out, which means basically you're being substituted out. They'll bring in another player to replace you. Now in algebra, what this actually means is that we are going to replace our letter variable. So we've got our letters. Remember what we call those? We call those our pronumerals, and our letter variables, we're going to change them and replace them with a number of a given or a known amount. And some of the questions that we see in our textbooks, in exams, that your teacher might do as worked examples, using substitution can be phrased in lots of different ways. So the question might use lots of different cognitive verbs or different words to ask you to substitute. And it's important to be exposed to lots of different kinds of questions like that, so that if you're in an exam and you're asked to substitute something, you know what it is that you're being asked to do. So we're going to actually look at some different types of examples today using different phrasing so that you'll get used to that. And it's important when we're doing substitution that we follow BIDMAS. Now I know this is called different things. It's called BOMDAS, BODMAS. I prefer BIDMAS. Let me just quickly take you through what I mean by BIDMAS. Brackets. So if you've got anything in brackets, we do that first. Anything with an index. The O for BODMAS stands for ordinals. It's not a word we typically use in the UK or Australia. It's more used in the USA, which is fine, but we're used to using the word indices, which is another word for powers. So if you've got anything with a power, a squared, a cubed, whatever, that comes next. Then D for divide, M for multiply, A for addition, and S for subtract. Now, typically what I see with these kinds of questions is that we're also quick to do this addition and subtraction. We've just got to remember that if there's other operations that need to be done first, follow BIDMAS. Okay, so let's get straight into our first worked example. We've got a few today. So here is some of the language I was talking about. In this case, they're telling you, given y equals 7, find 3y plus 4. So what that means is, wherever you see the number, the letter y, you're going to be replacing it or substituting it with the number 7. So we just basically swap it out. So let's have a think about what 3y plus 4 actually means. It's 3 multiplied by y, and then we add the 4 on. So in this case, our expression is going to become 3 times 7 plus 4. And this is where we've got to follow our BIDMAS, because we've got two operations here. We've got no brackets to tell us what to start with first, but we know that M for multiply comes for A with addition. So we're going to do that multiplication first, which will be 3 times 7 is 21. We add the 4 and we get 25. So let's have just a quick reflect back on this question. That word given is telling us to substitute y equals 7. So anywhere you see y, you're replacing it with the number 7. That doesn't mean it becomes 37 plus 4, because remember, y is 3 times y. Okay, also remember to show your working here as well. At minimum, show that substitution step. So here's our substitution step right here where it says 3 times 7 plus 4. That is the step you're going to want to at least show your working. You might be able to do the rest in your head. Have a look at how many marks the question's awarded in an exam. If it's worth 2 marks, in the UK, that means 2 steps of working. If it's worth 2 marks in some schools in Australia, that might mean 4 steps of working. I only see 4 here. Maybe that's 1 step there, 2 steps there, and maybe a full mark for the answer. Just be guided by what your teacher has told you that marks are worth. So if it's worth 3 marks, 2 marks, 4 marks, it obviously clearly means you've got to show some working. You can't just end up at 25. And this is why it's important that we don't rely too heavily on our calculators. I'll talk a little bit more about calculators later in the video, but it's important that you can do some mental maths here. It's a lot faster than sitting and working it out on the calculator. Okay, we've got another one here. Worked example 2. If m equals -3 and n equals 5, evaluate. Now remember what I said about language. If we just flick back to that previous screen, we're told given in this particular case and then find. In this case, they're asking us to do the exact same thing, substitute, but they're using different language again. They're saying if something's equal to this, then evaluate, which means work it out. Okay, so we've got a fraction with a 3m plus a 2n, and the answer is divided by 2. So once again, we've got negative numbers. We need to be really careful. I talk about negative numbers in all my videos usually, and they're pesky. They cause us to make silly mistakes. So just remember our rules for negative numbers. If you've got to multiply two negatives, it becomes a positive. If you've got to multiply a negative and a positive, it's a negative. So when the signs are the same, the answer will always be positive. When the signs are different, then you'll get a negative number. Okay, so just be careful. So in this case, we're now replacing the m with a -3 and the n with a 5. I'm actually going to use brackets around those. You'll notice that there's no brackets in the original question, but what this does is keeps that -3 with the 3, keeps the 2 with the 5, and it keeps that plus separating them separate until I've done the two multiplications. It just means that instead of writing out 3 times -3 plus 2 times 5, you've got a minus, a times, a plus, and a times. That can get tricky, and so I think sometimes when you put those brackets around it, it just simplifies the results for you. So if we do what's in brackets now, we've got 3 times -3 is -9, and we've got 2 times +5, which makes +10. So now we've got -9 plus 10. Another way of writing that would be 10 take away 9, which is 1/2. So our answer is a half. Once again, negative numbers. Adding negative numbers is really tricky for some people. I always suggest that you draw a number line down in your book if you're not allowed a calculator. So quickly draw a number line. Remember, if you're starting on the negative side and you're adding 10, you're moving up towards bigger numbers, not down towards smaller numbers. Worked example 3. So if we look back again, different language again. This time we're told to calculate. Here we're told if, evaluate. Here we're told calculate this when these numbers are equal to these letters. So we've got an a² plus a 4b minus c, and this time a is a negative number, b is a negative number, and c is a positive number. So we've stepped up the complexity. We've now got 3 substitutions to make. Good idea again would be to use brackets. So firstly, I've put that -4 from a here goes into the brackets, and we're squaring the result where we've got the 4 times the b, 4 times -6 into brackets, and -7 comes out the front here. Now I'm just going to do this in small stages, and this is where you need to be really careful with calculators. And I would suggest right now, while you're watching, pause the video, go and grab your calculator. And if you insert into your calculator -4 and just press the squared button, it's going to give you a negative number. In fact, it'll give you -16. Now, we all know that a negative number times a negative number is a positive number. And when we square a number, we're multiplying it by itself. So we're doing -4 times -4, which should give us +16. However, when you do it on the calculator, it's going to give you -16. The question is, why is it doing that? Well, the reason is your calculator is also using BIDMAS. What it's seeing is -4 squared with no brackets. So what it does on the calculator is it's following BIDMAS. It does the I for indice first. It does the 4 squared first, which makes 16, and then it puts the minus out the front, which is the S for BIDMAS. So your calculator is not as smart as you are. You know that you're multiplying -4 by itself. So pop it in the brackets if you need to use calculators, but you should be able to do -4 times -4 in your head. So that makes a +16. Then we've got 4 times -6 makes -24. So we've got +16, take away 24, take away 7. Now, we know that if we've got 16 and we take 24 away, we're going to end up with a negative number. Take 7 away, it's going to be an even smaller negative number. So just be aware of that. So if I've got 16, take away 24, I'm going to get -8. Take another 7 away, I've got -15. Worked example 4. this one here has a square root symbol here, which is kind of like an I for an index. Now the tricky thing is here, I've got x squared plus y squared underneath the square root sign. It's very tempting to think that you can just cancel the square root out with the squared. You cannot do that. You have to do the addition under, which sort of doesn't seem like it follows BIDMAS. You've actually got to square the two numbers first, add them together, and then do your square root afterwards. That's probably one of the only exceptions to the BIDMAS rule. So in this case, we've got an if and an and a find the value. Once again, notice the language is different to here where we've got a calculate and a when. So we've seen givens, we've seen evaluates, we've seen substitute, we've seen if, then, we find, calculate, work it out. So just be aware, lots of different language. We're just replacing the x with a 4 and the y with a -3. So once again, our expression is going to become, and I've put those in brackets again, 4 squared plus -3 squared. So let's do what's in the squareds first, becomes 16 plus 9. So let's do the addition, which is 25, and then we take the square root of that and we get 5. Like I said before, it's very tempting to think that you can actually just do a cancel and a cancel with these squares, but you can't, because this plus here means that it's actually this answer here that is having the square root taken of it, not the individual parts of that. That's just something to be aware of. Okay, well, did you find this video helpful? I sure hope so. And if you did, there's some great ways you can engage with our channel here. Tell us in the comments. You could share the video on social media with a friend, family member, or a teacher. Also, like and subscribe and hit the notifications bell so you'll always know when the next video is out. And we've got loads more to come in this series. We're starting down at the juniors, but we're moving up towards some complex maths. So get ready and hold on to your seats for that. If you've got any questions, you can get in touch with us at mcclutchymaths@yahoo.com. You can also message on Facebook Messenger or Instagram as well. If I don't get back to you straight away, chances are I didn't get a notification for some reason, so try again another way. I always want to get back to you within 24 hours. That's my goal. Well, thank you so much again for watching me here at the channel. I'm Natalie McClutchy. Have a wonderful day.